E equals HV, and your H is a constant, which we'll get into, and your actually it should be HF, and that's your frequency. And then the E is your energy. So yeah, here we go. So your E is your energy and joules, and your H is something that's called Planck's constant, and it's this number right here, and then your frequency in hertz. You may have seen this in chemistry. When I used to teach chemistry, we would do this formula a little bit to get the energy of like our electrons and stuff like that. And then this is so super important. I used to make my students memorize it. I don't think they require you to memorize it here. I think it's on your formula sheet, but 3 times 10 to the 8 is your speed of light in a vacuum, and they actually call that C, although I haven't actually seen it written as C anywhere in this unit that I've seen. But C is technically like E equals mc squared, if you've heard of that Einstein quote, that Einstein formula. That C in there is the speed of light in a vacuum. That's this guy. So that's where Einstein got that. So that 3 times 10 to the 8. So that's basically like the speed of light, or the speed of an electromagnetic wave in a vacuum, any electromagnetic wave. So then we've got these math problems, and Caroline, these math problems, they use the same formulas that we used in the previous unit. So this will probably help you. So your velocity is equal to your wavelength times your frequency. Yeah. And so if we want to know, this is an electromagnetic wave. It says it has a frequency of 5 times 5 times 10 to the 9 hertz, and then it's in a vacuum. That's important. And then it says, what is the velocity? Well, since it's an electromagnetic wave and it's in a vacuum, it's 3 times 10 to the 8th. We don't even have to do any math. And this velocity only works for electromagnetic waves. But anytime they ask you this, it's 3 times 10 to the 8th meters per second. That's your velocity of an electromagnetic wave as long as it's in a vacuum. And I'll go ahead and tell you, every math problem on the electromagnetic test asks for in a vacuum. And so you know that the speed is going to be your 3 times 10 to the 8th. Then if we wanted to do our wavelength, we can take this formula and I call it putting it in the triangle. I don't know if they did this at your other school, Caroline. Some teachers think that it's cheating to use the triangle, but I think it's just, I guess being lazy, and I'm lazy. So if I want to search for wavelength, I'm going to do wavelength is equal to V over F. And so then I'm going to have my 3 times 10 to the 8th over 5.5 times 10 to the 9. And this is the same wavelength formula or velocity formula that we use in our waves unit too, Caroline. So it's, at least it's a formula that you've seen before. So I'm going to go ahead and I'm going to put this in my calculator. Okay. So I got 0.0545. Okay, and that's going to be in meters because our velocity was in meters. And I know that seems about right to me because my exponent on the bottom was bigger than my exponent on the top, so I know I'm going to get a number that's less than 1. And so that's a way for me to kind of, check myself. Now, when you're doing these tests, make sure on the test in my class that you show your work and then show your answer. If you just do the answer, you only get like 1 point. Basically, all the short answers are worth like 2 points apiece. And one of those points is for showing your work, and one of those is for the right answer. So like all the time I get students and they'll just put the answer and it'll be right, but they only get half of the points. And so, then they're getting like a B or a C on their test instead of like an A because they just, forgot to show their work or chose not to show their work or whatever. And then if we want to do our energy, right? We can just take that Planck's constant, which I do not have it memorized. That's why it's a constant. And on the test, they actually give you Planck's constant. They have that number there in the problem. So you don't have to worry about trying to memorize that. I checked, and they do give it to you on the test. Times 10 to the negative 34. And I'm going to put my frequency here. Make sure when you're putting these in your calculator that you put parentheses between these two. If you don't, because you've got these exponents, your calculator most likely won't give you the right answer. And the last thing you want to do is do all this work and not get the right answer. Okay, divided by, I'm just putting it in my calculator right now. And so I got 1.2. Oh, wait, I divided them. I was like, so I got 1.2 times 10 to the negative 43. And I looked at it and I was like, okay, negative 34 times 10 to the positive 9. That doesn't make any sense. What did I do wrong? Oh, I divided. So if you kind of have an idea of what your exponents are supposed to look like before you start doing your math, then if you get an answer that doesn't seem right, you can kind of check yourself and make sure. See, this sounds much better. I got 3.6 times 10 to the negative 24. Okay, that makes much more sense, right? Because I've got a negative 34 and a positive here, so this positive is going to kind of lower this negative a little bit. Okay, so now it's negative 24 instead of negative 34. Okay, so, and it's in joules because that's your energy. Now this wavelength formula, you will have problems like this on your wave test, Caroline. Well, I know you're not taking the wave test, but is in the waves unit, but this energy is a new thing for the electromagnetic unit. And so then they have another one where in this one they're giving you the wavelength and then they're asking you the velocity, the frequency, and the energy. Again, because it's an electromagnetic wave, your velocity is that 3 times 10 to the 8th. Okay, it's going to be the same as it was in the previous one because it's an electromagnetic wave and it's in a vacuum. Okay, to get your frequency, you can use that same formula. V equals wavelength times frequency, and we are looking for frequency this time instead of wavelength. So I'm going to make my triangle. I'm going to put my wavelength here, my frequency here, and my velocity here. Since I'm looking for frequency, I'm going to cross that out. I'm going to have F equals velocity over wavelength. Okay, so I'm going to have 3 times 10 to the 8th over 3.2 times 10 to the negative 2. Now these are like the same problems on your test, I just kind of adjusted the numbers a little bit so they're not exactly the same, but they are basically like um, they're asking the same thing, if that makes sense. So I've got 3 times 10 to the 8th divided by 3.2 times 10 to the negative 2, and I'm getting this big number, 9.3 9.375 times 10 to the, let me look at my calculator. Times 10 to the 9. And that's going to be in hertz. Okay, now if you were putting this, say you have a graphing calculator, and you were putting this in your calculator all at once, you'd want to make sure that you put parentheses around each of these right here. That way you'll get the right answer. Otherwise, it'll divide in the wrong spot and you'll get the wrong answer. Okay, so this was our frequency, 9.375 times 10 to the 9 hertz. And then if we wanted to solve for our energy again, we could do energy is H times F. And again, in the test, it actually gives you this number, this 6.626 times 10 to the negative 34. This is, they call this Planck's constant. And I think there's a question on the test. Now, when I say there's a question on the test, you guys might take your test and go, well, that question was not on my test. And that's because there's a huge test bank. And, it just pulls a couple questions for you guys when you take the test from the test bank. So, you might go, oh gosh, that part was really hard for me and I didn't have any questions about that on my test. Well, that's just because, you got lucky because that part wasn't, that question just ended up not getting pulled for you. Times 10 to the negative 34. So do you see how we're doing times 10 to the 9 again? For so then negative 34 into the 9. So we should get something like 24 again, which I actually did get. I got 6.21 times 10 to the 24. Now, a lot of students ask me about Sig Figs. Honestly, I could care less about Sig Figs. So, as long as I see your work and all that, and I can see where you're going with it, and you get, whether you put 3 things after the decimal or 1 or 2, I don't really care. If you put 6 times 10 to the 24, I know you got the right answer. I know that you did it right. So, and it's in joules because this is energy. And then I think there's like one more math problem they had. Yeah. And so this is the last type of math problem that they have on the test. You may not get all 3 of these. You may just get one of these 3 pages when you take it. So electromagnetic wave travels in a vacuum. A photon has 8.5 times 10 to the negative 22 joules of energy. What is the frequency? So for this one, we're kind of doing it backwards. We're going to use this formula first. Okay, and we want the frequency, not the energy. So I'm going to use my triangle again. I'm going to put H and F together on the bottom and E on the top. And all this triangle does is just saves me from doing some algebra. And I want the frequency. So I'm going to do F is equal to E over H. So I'll have 8.5 times 10 to the negative 22 over that 6.626 number. To the negative 34. Okay, now remember when you put this in the calculator, make sure you put a parentheses here and parentheses here if you're putting it in the calculator all at once. Some people like to do it in steps. Like for example, I'll put this in the calculator, hit enter, and then hit divide, and go from there. But I don't have a graphing calculator. I had one, and my husband needed it when he went back to school, and then I never saw it again. So I don't know what he did with it. It's probably still in his backpack. Okay, so I got this huge number. So let's see, 1.28 times 10. I'm gonna have to count. 1, 2, 3. I wish you guys could see my calculator because it literally has like, it's just the one on my computer, so it has like 30 spaces of number. So it's 1.28 times 10 to the 12. Okay, which kind of makes sense because you would do like 34 minus 22 is like 12. So your velocity. Again, we don't have to do any math for that. It's an electromagnetic wave. It's in a vacuum. It's 3 times 10 to the 8th. So if this was on your test, you obviously wouldn't have to show any work for your velocity here because, no work is needed. You could just say, you could just write 3 times 10 to the 8th and you would get all your points for that. So, and then if we want to do our wavelength, our velocity is wavelength times frequency. So let's put this in the triangle. We want wavelength. So we'll do wavelength is equal to V over F. So we'll do our 3 times 10 to the 8th. Over, what was that frequency we got earlier? Now on a test, let's say that you did this part A, what is the frequency, wrong, and you got the wrong answer for that. If you need it for another part, like this part, this third part right here, and you put your wrong answer in here, right? You'll get a wrong answer for your wavelength, but as long as you use this wrong answer correctly, if that makes sense, like say you had 3 times 10 to the 12, as long as you use your 3 times 10 to the 12 correctly, whatever I would count, I would give you full points for this part, because otherwise it's kind of like double jeopardy. If you get it, you get the answer wrong up here, but then you need that answer for this next part, and then you get it wrong down there, then you're kind of, I'm counting that one wrong twice, basically, which I don't really think is fair. So as long as you use your wrong answer correctly, I'm giving you points for that, which that's how they do it on AP exams. So I figure if it's good enough for the College Board, it's good enough for me. So we've got 2.34 times 10 to the negative times 10 to the negative 4. Also for these, if you had put like 0, 0, 0, 0, 2, 3, 4 meters, you would get points for that too. So, you don't have to write in scientific notation in order to get the right answer. So this one would be like 2.34 times 10 to the negative 4, which makes sense because our exponent is larger on the bottom, which means we're gonna end up with a smaller number